The Sun, the source of all natural light and heat in our solar system. All life depends on it. But everything has a beginning and an end. It's a life cycle that applies to everything, including our Sun. So today, we will be diving into the life cycle of stars, also known as stellar evolution. It all starts with interstellar clouds of dust and gas, known as nebula. This is the birthplace of every star. All this dust and gas clumps together to eventually form into a more dense and compact object known as a protostar. Gravitational contraction plays an important role in the formation of the protostar. With so much pressure, density, and heat due to increased collision between atoms, it is now possible for nuclear fusion to take place. Nuclear fusion is a process whereby hydrogen atoms are combined and converted to helium. This process creates even more heat and light. Not to confuse fusion with fission though. Fission is splitting atoms to create heat, like in nuclear power plants. Anyway, over time, the rate at which nuclear fusion occurs increases until the amount of energy produced at the core equals the amount of energy being radiated from the surface. This basically means that the force of pressure from inside the star equalizes with the force of gravity pushing against the star. This balance is what prevents the star from collapsing under its own weight. This begins the transition from a protostar to a real star, also known as the main sequence star. The main sequence of a star begins when a protostar ends its reliance on gravitational contraction and relies completely on nuclear fusion. Most of a star's life is spent in this stage. The star will keep converting hydrogen to helium in a process that produces immense amounts of light and heat. It is important to remember though that there is one factor that influences almost everything about a star: mass. Small red dwarfs live for about trillions of years, while giant blue stars are hotter and last for only a few million years. Our star, the Sun, is classified as a medium-sized yellow dwarf and has a life expectancy of about 10 billion years. Our Sun is currently in its main sequence and is halfway through its life. But just keep in mind though, that soon, the hydrogen will run out. The star does not have infinite amounts of hydrogen gas, so sooner or later the hydrogen will be depleted. This means that nuclear fusion will no longer be possible, and the demise of the star soon follows. The end for each star is different, and depends on how big the star was. Our Sun, which is relatively small, will swell into a red giant, consuming its solar system, and then eject all its outer layers, leaving a small dense core known as a white dwarf star. The dwarf star is surrounded by planetary nebula, which consists of the outer gases of the star. Planetary nebula are some of the most spectacular sights in outer space. Massive stars, on the other hand, will go supernova in a large explosion. Then, a neutron star will be formed if the star is massive, or, for the largest stars, a black hole will be formed. Neutron stars and black holes are some of the most amazing things in the universe, and I'll probably be talking about them in another video. But until then, thanks for watching and see you next time.